Question 8 is on carbohydrates, which is some of the new material they taught between the third exam and the final. And what they are asking you to do is take this Haworth projection and turn it into a Fisher projection, the one where you have the lines going across like this. The first thing to do is recognize whether this is a aldose or a ketose. And the way you do that is by finding your anomeric carbon, the carbon that has two different oxygen bonds on it. And so that is this carbon over here. This carbon is connected to the oxygen of the ring and then an OH group. And now, if this was an aldose, it would only have the OH group. But it doesn't. It has a CH2OH group as well. Whenever you have your anomeric carbon having a CH2OH, you are dealing with a ketose. And what that tells you is starting out at the very top of your ring, at the very top of your Fisher projection, you will have a CH2OH. And then the next bond down, you will have a double bond O. And now I'm going to number this 1, 2, 3, 4, 5, and I should probably make sure I know how many carbons there are. So 1, 2, 3, 4, 5, and 6. So I have 6 carbons altogether, so this should be a 6-carbon chain. The carbon on the bottom, regardless of whether it is an aldose or a ketose, will always be a CH2OH. So I've got 3 of the carbons filled in, and now I just have to figure out carbon 3, 4, and 5 based on the OH's positions on here. So let's start with 3 and 4. Carbon 3 has its OH pointing up, and carbon 4 has its OH pointing down. For these carbons, there is one set of rules, and that is if you have a Haworth projection, in your Haworth, if the OH points down, when you draw your Fisher, the OH will be on the right. And opposite that, if the OH points up, then the OH is on the left on the Fisher. So that means for carbon 3, the OH is pointing up, so the OH is on the left, and that means the hydrogen is on the right. For carbon 4, the OH is pointing down, which means the OH is on the right, and the hydrogen is on the left. Now carbon 5 has its own rule because this is your penultimate carbon, the carbon that is second from the bottom. Because when we look at the Haworth, carbon 5 doesn't actually have an OH. It has a CH2OH, and that's why the rule changes. For your penultimate carbon, the rule is in the Haworth, if your CH2OH is pointing up, when you draw it in the Fisher, your OH on the second to last carbon will be on the right. So this rule is basically opposite the rule we have over here. And so, just continuing it, if the CH2OH is pointing down, then the OH is on the left. However, in this example, the CH2OH is pointing up, which means the OH is on the right. And so this would be the Fisher projection of the ketose that they gave you. And that was choice A. So the answer to this question is choice A.